All right, so we're going to do number 41, EOC review, and carry on until this is super long or I don't have any more time. So we have a travel bottle that is 1/3 the volume of its standard size bottle. So how much different is it? That's what they're asking. So remember, when volume, the units in volume are units to the cubed. So you take the scale factor, which here is 1/3 the size, and you cube it. Right? That gives us a weird number. I'm going to change that to decimal form. It's a 1 to 27 ratio. Right? So it's 1/27 the size. Travel is 1/27 the size of the standard, right? Or standard is 27 times larger than the travel. Okay, so this is the T and this is the S. Okay, so there's that one. All right, so here we have a town, has a city, 23, town has 23 city blocks. All right, so it's 23 blocks per town. Okay, and there is 1/4 quarter mile is per block. So each block is 1/4 mile. Has a dimension by 1/4 mile by one. So a block is 1/4 mile, 1/4 mile. Okay, so what is the area of the block? Well, the area of the block is quarter squared is an 1/8. No, 1/16. So the area of the block is a 1/16. Is a 1/16 of a 1/16 of a mile, of a square mile. Careful how they 1/4 by 1/4. They give you the dimensions. They don't give you the square mileage. Okay, so you gotta make sure you put the right units down in there. Okay, and there are 4,500 people in the town. Okay, what is the population density? Okay, population density is the number of stuff per area in a single unit, 1 unit of area. Okay, so our answer needs to be in people per square mile. That's what we need to be in. Okay, so we need to start with people on top of our thing. So we have 4,500 people. 4,500 in our railroad tracks, right? This is a unit analysis, right? So we have 4,500 people in our town. Okay, and then what is our unit that has town in it? Blocks. Town's got to go on top, and blocks go on the bottom. 23 blocks go on the bottom. All right, towns cancel out. Doop-a-doop. And now we have peoples per block. We need peoples per square mile. So we're looking for blocks, and we have square miles there. That's convenient. So blocks go on top, BLOCKS, and we have this 1/16 per mile squared. Now watch this. if you have a fraction in the bottom, okay, your numerator in the bottom and of that fraction stays in the bottom. Numerator stays in the bottom and the denominator goes to the top. So that means there's 16 blocks per square mile. Man, I love unit analysis. It's like magic. Okay, so you can, or you could have been like, okay, 1/16 is 0.0625. You could have also done that, and that would have been 0.0625 on the bottom, and the math would have worked out either way. But fractions are shorter. Okay, to write. So you go 4,500 times 16 equals 2,300, or divided, so you multiply everything on the top, right? Then you divide it by everything on the bottom. Okay, 4,500 times 16 equals, I forgot to cross out the blocks, right? Divided by 23 equals 31. I'll round it down. 3130 people per square mile is what I end up having. And if say I did use, my alternate way and you did it in decimals, right? And it was just what's 1/16 in decimal form again? No, 1/16 was 0.625, right? I just do 4,500 equals divided by 23. That's only 19. Divide that by 0.0625. That's supposed to be a 0 there, right? That equals the same thing, because when you divide something by a number smaller than 1, it makes it bigger. Okay, so that is shown that it works either whether you use decimals or you use fractions.